Welcome to the Apex Energy Podcast. I'm your host, Sam Al-Qattan. Today, I have with me Dr. Sara Pugh. She has a PhD in biochemistry, and she helps people improve their metabolic, mental, and physical health using psychiatric nutrition, ketogenic diets, fasting, hypnosis, targeted supplementation, and Pilates. You can find her on her YouTube channel called Busy Superhuman. How are you doing, Dr. Pugh?
Yeah, I'm good, thank you. Thank you very much for having me.
I appreciate it. Yeah, thank you for coming on. I'm really glad to have an expert on the subject of quantum biology because I've just been doing a deep dive into some of the stuff I've been seeing on the internet, but it's great to talk to an expert. I'd like to start actually first, if you don't mind introducing yourself, just doing a personal introduction, something that maybe I missed.
Oh yeah, no, you did a really good job. I also did biophysics at university, so I did a PhD. It was more biophysics than biochemistry, and that's how I got into quantum biology originally. That was a very long time ago. And then I've obviously, over the years, realized that movement's really important, mindset's really important, biochemistry is really important. But then within the last about 7 years, I've realized the importance of light and water, and then later on magnetism. And I've been able to join the dots to make sense of why people feel good or why people don't feel good. And that's what I currently do now. I work with clients, but I mainly make content and courses because I like sharing the information. So I'm really delighted to be here with you to talk about quantum biology.
Awesome. So let's dive into the light thing now that you mention it. What, how important is circadian health or light within a human being?
I would say it's probably the most important thing because our light and dark cycle is basically what drives our cell cycle at the molecular level. And if you've got a messed up cell cycle, it's not only your organs that are going to be malfunctioning, but also at the cellular level. So the mitochondria, the way in which the cell performs metabolic activities. So the way in which light influences us is enormous. I mean, people think about it just from going to sleep or being awake, but it's from every large part of us all the way down to very tiny parts, our mitochondria, because they're inside us and they rely totally on light signals from the outside through our eyes and skin, and to some extent information via light in our food, to know how to regulate our genome, how to adjust our energy needs. They also aid with immune system management. So I think just very basically, as Dr. Cruz would say, light is the primary driver of metabolism.
Yeah. Okay, awesome. And I'd love to just touch on some of those points. What, how do we know that there's different spectrums of light, right? There's visible light, and on the low wavelength end we have UV light, and then on the other end we have infrared light. Is that right?
Yes, that's correct. And
Okay.
also, and
And
all of our biochemistry and ourselves have evolved just for the wavelengths you've described from the sun over millions and millions of years. And then the new wavelengths we've introduced, like radio waves or microwaves or Wi-Fi, that's also light, but we can't perceive it in the same way as we would visible light, but it has an impact on our biology as well.
okay. And I'd like to just ask specifically, I know that different parts of the electron transport chain within the mitochondria, within the mitochondrial membrane, get affected by different wavelengths of light. Could you maybe tell us what different parts, complexes are affected by the different colors of light?
Oh, yeah, sure. Well, in the mitochondria, we've got the electron transport chain, or we could call them respiratory proteins, and there are 5 of them. And the electrons travel down, and then the ATPase spins and ATP comes out. That's the magnetism part, the spinning of the mitochondria. And these different respiratory proteins can be different lengths apart. And the closer they are together, the more efficient the electron flow, and therefore the more efficient the mitochondria. And complex 2 to 5 are red light activated, and complex 1 is a UV sensor. And this is interesting because this means the mitochondria know whether we got our food from a carbohydrate source or from a fat source, because carbohydrates or plants grow in sort of long durations of UV light, and the electrons from the food carry information, and the electrons from carbohydrates will go through 1 to 5, and then the electrons from fat will go from 2 to 4. So that's how the different wavelengths of light, just in a simple way, can be sensed by the mitochondria directly in the electron transport chain, in terms of how does a mitochondria know what we ate.
Perfect. And yeah, I was thinking this while I was doing some research. We know that red light, or light that has a longer wavelength, we can say, penetrates a couple inches deep into the skin. Is that correct?
Yes.
Yeah. So I could understand how light could directly affect mitochondria in our entire body, the red light. But how does UV light, a light with a shorter wavelength, penetrate and get inside of our bodies?
Well, first of all, we can make UV light ourselves, but secondly, it's the UV, you're correct, that it hardly penetrates at all, I mean millimeters, but it's the transfer of information via the information in the electrons in the spin. But also our bodies are a photo amplifier, so a small amount of photons in our eyes and our skin is going to be amplified through the body, effectively like a light show, and then that information can be a small signal can be amplified into a large signal into the mitochondria. But also, in terms of properties of light, UV light can change matter and red light can move matter. So via red light and water, that's how the ATPase, actually the motor, runs. There are other things which red light do as well, but fundamentally the red light is able to cause the ATPase to spin faster, and it doesn't matter whether you've got electrons in the chain or not. The ATPase is still spinning to make ATP. So that says we can make energy without food. And also, when it comes to other regulatory factors in the mitochondria, UV light can change matter. So it's responsible for producing different neurotransmitters, for example, dopamine and serotonin, via aromatic amino acids, as well as other compounds that are very powerful, like endocannabinoids. So indirectly, the UV light is able to propagate its message through the body, either via the information in the electrons, but also the way in which the UV can create hormones or neurotransmitters in us, which then are going to have an effect. Because dopamine is sort of if you're high dopamine, you're going to be a high energy person. So along the chain, there's a communication between that dopamine and how we'll just say how much energy we have per se, because there's so many different ways to describe energy in the body, and high dopamine is just one of them, along with what I just said about good mitochondrial function. That would also provide good energy and good redox.
Yeah, no, that's actually, I started this channel and my aim was to beat chronic fatigue, because I had struggles with them in the past. And I kept trying to define, on a biological level, what does it mean to gain energy? And I came up with the same exact things that you're talking about with mitochondrial function, as well as dopamine. And those seem to be the main drivers of what we call high vitality, high energy. And we might even be able to lump in adrenaline and some stress hormones in there. Would you agree with that as well?
Oh yeah, I think noradrenaline definitely. People always chase a noradrenaline kick, and an adrenaline kick would be horrible. But also the other fundamentally important part of our battery and energy is, first of all, our exclusion zone water network, because the way in which the exclusion zone is formed, it effectively forms a battery, and then we can behave like a solar panel, like as in Einstein's photoelectric effect, where we can gather energy from the sun in the form of photons, which are going to excite electrons. And again, there's the red light in the sun, which is able to expand our exclusion zone, and also ultraviolet light also expands the exclusion zone. So again, like I was saying, we can make our own UV as well under certain circumstances. So it's part of our communication system. So the water battery is fundamentally important for as we per se energy, as is the redox potential, as in we're meant to be at a negatively charged, like 400 millivolts would be ideal, but then say someone with chronic fatigue, it could be something below 200 millivolts. So we're basically viewing ourselves as a battery, but then the water network can transfer sort of vibrational energy through the body, but also there's the DHA as well, which changes light into direct current, because we're a direct current or DC organism, into direct current and then back into light again. So if you don't have enough DHA, it would be like not having sufficient wiring in your body. So there's more than one factor to this, what's energy. But then we have to remember that our mitochondria make water, and that's the energy source they provide. Because from Gilbert Ling's work, it's not possible for ATP and the high energy phosphate bond to provide a human with enough energy to function. It's out by orders of magnitude. So this idea of having multiple batteries, or not multiple batteries, multiple energy systems that all need to connect in order for us to have enough power or energy. But also vitamin D is really important in this as well, because that's something that's able to trap energy as well and communicate information and light around the body. So low vitamin D levels often correlate with bad health or poor immunity. And again, it's a cancer risk because you just simply don't have enough energy to run the correct cycles in the body.
Interesting. And what about grounding? I hear Dr. Cruz talked a lot about combining grounding with light exposure, and how grounding allows us to collect more electrons, and through the photoelectric effect, those electrons can be affected by the light. Is that correct?
Oh yeah, definitely. So you can gather electrons via the grounding, and it doesn't necessarily have to be standing barefoot on the earth. You can touch plants because they're grounded. Then metal is obviously a conductor. So in some houses, taps and the plug hole in the bath is also a connection to earth, and concrete will conduct. So sitting on a concrete bench outside, just for anybody listening who's got an aversion to bare feet on grass, but that's a good point, because the more electrons we can draw in, that means we've got more electrons that can be excited by the photons or energy from the sun. So again, yes, sun exposure and just the absolute exposure to light for setting our body clock, that's one way to look at it. But in order to get a better effect, the more electrons you've got, the better the effect from the sun's going to be. But it also comes down to not just grounding, but not leaking energy and electrons either, because that's a big fundamental part of biology, especially quantum biology. If we're constantly leaking energy, that's creating a situation in the body where it's constantly wanting to store energy. So an example would be something like diabetes or obesity, an excess of energy in the person, as in matter or glucose or fat, but it's because they have a deficit of the correct form of energy. And also the interesting thing about grounding is it's not just absorbing electrons, it's also infrared as well. Say going outside and say camping, for example, if you've really messed up your circadian rhythm, going camping for 2 or 3 days is a really quick way to reset everything, because you're constantly in contact with the earth. And again, we're talking about the Schumann resonance as well, which is really important for us. So there's multiple facets to grounding, not just collecting electrons. There's more to it, and it's definitely not woo-woo at all. It's anybody who thinks that's very foolish, because it's one of these things. When I've been studying on myself and other people, what factors can I take away and put back in again? How does this impact the person? And I have tried out no grounding, but doing everything else right, and it's just not the same.
And why do you think there's such I don't know if it's a resistance. I mean, I'm obviously not in the scientific community, but how come a concept like grounding is not welcome? Since there are peer-reviewed trials that I've seen online talking about the benefits of grounding, how come it's not, I guess I don't know if it's a wrong assumption to say that it's not really accepted by institutions, centralized institutions, if you will?
I think because grounding's free, and it's again us losing connection with our ancestors, because they were all for sort of grounding, and they used to use leather-soled shoes and stuff like that. So it was just taken as normal that we were grounded to the earth. And then because people didn't really transfer the information from the ancients and our previous cultures into today's culture, because rubber got invented, people wanted to wear trainers and high heels and everything. The connection wasn't made unless it was somebody who was very in tune with nature. So say someone who was into yoga or other aspect. And they've always been those kinds of people. But the kind of people that continue to ground or go barefoot were just seen as hippies. Whereas now you're completely correct. There are studies on grounding. And I think the latest one I read was it's the best option for preventing or lowering the risks of cardiovascular disease. And there's numerous studies on grounding and blood flow and inflammation. But again, our blood is highly dependent on the exclusion zone. So as I was saying before, the more electrons and the more EZ water you've got, the better you're going to function overall. So there's lots of ways in which grounding has huge benefits. But the other factor about grounding is it's reporting on how much people are not inside. So if you're not outside grounding, you have to be inside, not connected to the earth. So there's that correlation as well, which if you do epidemiological studies, they say, oh, people that spend more time indoors are generally sicker. Nobody refutes that, yet it's blatantly obvious. It's either the sun or the grounding or both, or the fact people are being inside. But the fundamental reason is sometimes, like Einstein said, the solution is extremely simple. And biochemists and scientists love to overcomplicate things, and they always want something novel, or they want something patentable. But it also depends on the funding bodies, because when I was a scientist, you'd need to provide a sort of hypothesis, write a grant to get money. And if you wanted to write a grant about grounding, I don't think it would be funded, just because there's multiple reasons. It's not novel. It's it's not going to produce a pharmaceutical that can be patented, but also it's just so simple as well that it's partly the fault of scientific research, because there's many issues I have with that. It's useful, but you mustn't ever take it as gospel, and it's distorted as well. But I think it's now coming more into the forefront about grounding, because just back to, because you mentioned I was a Pilates teacher, and I think a lot of the time Pilates and yoga work, even inside, is people are just not wearing shoes. So the act of taking your shoes off, even inside, especially if you're lower down on the ground floor, there's still an extent of sort of connection to earth. And that's why sleeping downstairs is better, and sleeping higher up. The higher up you go in a flat or a hotel, the worse the problem. And there have been studies on the further away people are from the planet, the worse the problems get. So there is research. You just have to sometimes piece it all together. And it's one of these things. What I like about quantum biology is it's so obvious. You can say to your client, well, why don't you just try it yourself? And they'll feel the difference straight away. So I think it's because it's right in front of our noses, hiding in plain sight. That's why I would say it's not researched as much as it should be.
Okay, gotcha. And I think, yeah, there's a lot of hope. I mean, psychedelics now are just being openly talked about and researched at universities. Same with cold thermogenesis. So I hope that grounding will join them shortly as well. I'd like to shift over. Sorry, go ahead.
You've got to bear in mind with psychedelics, there's going to be lots of venture capitalists lined up to make, because you can make analogs, you can get things like PLSD, and you can get slight variations, and that can mean you can patent, because you can't patent these natural products because they fundamentally are. And things like MDMA, they're too old because that was invented over 100 years ago. So all the patents on anything useful in the psychedelics front, there's no money to be made. So but also, again, it's a demand, because somebody somewhere is going to be able to make money from it, because somebody's got to produce these compounds. And also you need therapists or people to actually perform these therapies. So again, indirectly, there's money involved with the psychedelics. They're quite interesting, though, because they reset photoreceptors in our eyes. That's one of the ways in which people find them to be hugely beneficial. But that's a whole other topic. We will not go down there.
I want to ask the basic quantum biology questions, but I actually really want to go down that rabbit hole. And you sparked some curiosity. How would psychedelics affect the quantum biology and the magnetism in the water within a person? Because we already know from Dr. Robin Carhart Harris's lab. I don't know if you're familiar with her. He's at in London, and he came up with this hypothesis of the entropic brain theory that communication between different parts of the brain dramatically increases on a psychedelic trip, very similar to neurogenesis in children and in young infants. So I'm wondering, if there's such a strong effect neurobiologically, how would that translate? I mean, some of this I'm sure would be conjecture unless you have some studies to quote. How would it affect the quantum biology psychedelic?
I know the most about the maps and the MDMA, and I'll just go along that because another very important part of quantum biology is our thoughts and our emotions, and things like MDMA produce a huge feeling of being connected to other humans, rapport. It produces vast amounts of all of the neurotransmitters and also oxytocin because it's part of bonding with other humans. And yes, you can produce your own oxytocin by doing a cold face plunge or cuddling, but then again, the oxytocin is really, really high up in the hormone hierarchy, so it's tying into that aspect of quantum biology. But also oxytocin is a bit like BDNF. It can encourage new neuronal growth and to some extent possibly repair. So it's along the same pathway as you just mentioned about neurogenesis. But then there's also the emotional and the thoughts and what we project into the quantum field. And I would say, knowing the most about MDMA, it's very good for letting people reprocess a trauma in a different way. And there is possibility, a very strong possibility, we store memories and traumas within our body. So if we can reprocess a trauma using, say, a psychedelic, we could potentially alter the structure of the memories that our water is holding in order to be able to move forwards and away from a trauma. So that's the PTSD side. Then I don't know for certain how it would affect, our relationship with light, other than just resetting the photoreceptors in the eye, which again, the eye is the heart of quantum biology. Because there are psychedelics that are in sort of the similar categories, like mescaline and LSD and psilocybin are all in the serotonin pathway, along with DMT. But DMT again is something that it's almost like entering another parallel universe. So it's like the part of where quantum physics and metaphysics and all of that join. And I 100% think we don't understand that yet. However, just very simply back to what you said, it can help us use parts of our brains that have maybe we've allowed to be dormant, and other parts of the brain have become too dominant, and that can cause all sorts of problems as well. So it can redistribute the way in which the brain is functioning so it's more even. But again, there is another level to it which nobody understands yet about where exactly do people go when they use DMT. I don't know. Is it like another realm? But that's also has been used for a long time for treating depression, because on a biological level it can reset receptors, the serotonin receptors at the membrane. But on another level, I think it's showing a person there's more to us than we think there are. And it also is excellent for just derailing bad habits as well, because it changes the way people are thinking. If you're constantly stuck in a very linear way of thinking, a psychedelic or even hypnosis on the right person is going to show them that the reality they thought they lived in isn't the case, and it gives them hope, and it opens doors to them to be able to shape their own realities, because we are sort of a conscious creator. So that's how I would say it's more that angle of quantum biology, the spiritual and the consciousness side.
I really want to understand the POMC gene and the POMC peptide. And from what I know, POMC is activated mainly through the leptomelanocortin pathway, which comes from light. And does the leptomelanocortin pathway, first of all, does it have to come through the retina and the eye, or can it be activated through the skin as well?
There's the most POMC in the stomach area, but and on the backs of the calves as well. But yeah, fundamentally, when it comes to light, the eyes are the best detectors of all. But we also want a signal from both, because if you only ever expose your eyes and you don't have the skin, somewhere along the line there's going to be a mismatch. So yes, it's both. And
Okay. And how does POMC what is it? Por opium melanocortin
yeah,
hormone gene, yeah. And it gets cleaved into a bunch of different important things in the body according to the spectrum of light that it comes in contact with. Could you tell us about some of those
Oh
different
yes,
cleavage points?
yeah, sure. So it's I think it's there are a few things that people don't really talk about that much with it, but there are some main ones which I think are really important for the listener. So with POMC, it's a peptide that is produced, and it can be chopped up into different smaller peptides. Depending on the wavelength. So, say if you went out naturally in the sun, it's going to be cleaved, and the main sort of products are going to be alpha MSH, which is for making melanin, but also this decreases appetite and increases sort of libido. Then you've got enkephalins and endorphins. So there are natural opiates, so that we're primed to feel good in the sun and seek it out more or become addicted to it. Then we've got ACTH, which raises cortisol, and then we've got CLIP, which is an insulin secretagogue, so it's going to affect insulin. And when things are all working properly and we're out in the correct wavelength, so it's mainly the UVA which activates POMCs when we're outside. Say if we came inside and we didn't have any other wavelengths, because even if you've got the windows not covered, the glass is going to block out all the UV, most of the red. So you basically are in a blue light environment, and worse if you've got screens on or artificial lights. So in this circumstance, POMC is cleaved more into ACTH, which is going to raise cortisol. So this means if somebody was sitting inside all day under blue light, they're constantly having their cortisol elevated. And if you allow that to happen, first of all, in the beginning, you're going to feel quite stressed. We live a stressful life anyway, so most people's cortisol is elevated to start with. And if you allow this cortisol to just constantly be high, there's going to come a point where the biochemistry just drops and you just flatline. So that could lead to something like adrenal fatigue. But also in terms of what we choose to eat or shouldn't eat, when you raise cortisol, you're going to raise blood sugar, but also CLIP is going to effectively act like insulin. So it's behaving like eating and storing energy or food. So in a way, people could technically create diabetes or obesity by sitting in blue light, because they're effectively releasing their own blood sugar and then sucking it into different parts, because that's what insulin does. It just opens GLUT transporters in a variety of cell tissue, including fat, so the glucose will go in. And because people are not aware of this, they're going to be continuing to eat in a blue light environment, and it may not necessarily be their food choices that's causing their weight issue. It's very likely their light choices. So when it comes to diabetes 1 and 2, blue light really is their nemesis, and those two groups of people really need to be careful with their blue light exposure, because they're already in a compromised situation regarding their blood sugar. But also somebody who's either very stressed or has got adrenal fatigue, again, they need to be careful with the blue lights, because the way in which POMC is functioning is not how it should be nowadays. Yes, when we were mammals underground without the sun, this was brilliant because we could make our own food, but it's not useful anymore because food is abundant. So that's, in a way, how POMC is really important, and how if you go out in full spectrum sunlight, the POMC is going to behave as nature intended. Whereas if you sit inside under blue light, it's going to create effects in your body that are undesirable, because we already have issues with excessive sugar consumption and stress. And then the blue light on top is just exacerbating a problem that's pretty much for everybody. So, and it also does dictate where people in certain places or what they should eat. Like in the UK, because we have blue light and non-native EMFs, eating carbohydrates, especially in the winter, would be pretty foolish, because our environment no longer permits that way of eating. If you went out and ate your carbohydrates in the summer at noon under UV light, under the sun in the UK, you'd have more wiggle room, but that's sort of going into the seasonal eating. So our light environment also can dictate what we should be eating, because some people think it's just doing blood types test, or they'll just go and look for some way of eating on the internet. But really, you should match your way of eating to what kind of light you're exposed to, because eating at the equator would be totally different to eating in Finland, because the light it's almost the polar opposite.
Yeah, and I'm trying to think of, like, I'm trying to piece this together. If a person was blue light toxic, their body would constantly be producing lots of ACTH through the POMC pathway, and the ACTH leads to an increase in cortisol. But what if a person sits outside in the sun all day? Wouldn't that also lead to the same? Because there's blue light within the sun as well.
It's blue light in the absence of other wavelengths. So when you go out, because the blue light from the sun is a different Kelvin, different to the light that comes out of a light bulb or a computer.
I'm listening. Sorry, it's just
yeah. So the blue light from the sun is different to the blue light that comes out of a computer or a light bulb, because basically the light that comes out, in simple terms, is just constantly telling your brain it's 12 noon, but inside you don't have other wavelengths. Yes, you could have a UVA light and you could have a red light on with you inside, and it's going to deal with some of the problem, but it's still, you can't create a sunshine or a real sun inside. But for people who are trapped inside, I mean, I've got a UVA light there, and I do often use a red light at the same time when I'm using devices. So you can mitigate it if you're inside, but fundamentally when you're outside, you're in full spectrum sunlight, and blue balances red all the time, and that's the key factor. And then UV is there some of the time in the day, but there's always this particular blend of blue and red that our bodies respond to. And a sunrise is not the same as a sunset, that the blend of blue and red are slightly different. So our biology does know the difference between a sunrise and a sunset, even though to us it looks the same, except the sun's just on the other side.
Yeah, what causes that? I'm wondering. I mean, sun rises in the east, sunset is in the west. I mean, it seems like it would be the same solar angle. I'm not sure. Is it just the way, like, do you have an explanation for that? Why the sun?
I'm not an expert in like sort of planetary alignments, but I just know from when people have they've examined the light using a spectrophotometer, it's very similar, but it's not the same. But
Okay.
also, I don't know the exact reason. So it's similar, but the other difference about the sun in the morning is we see the sunrise and get the blend of the blue and the red, and this switches on particular hormones in the pituitary gland. But then later the UV light comes and switches them off again. So the sunset is different because there isn't going to be any UV later. But also this all comes down to our circadian rhythm, that our bodies intrinsically know when we should be going to sleep and waking up if we give it the correct light, because we all know people that pretty much live indoors and they still function as a human being. So the little light that they get, even if there's a very small amount of actual sunlight, they're still able to run to some extent, but not properly. And then that's sort of the window into disease. So there will be a small amount of other photons of light that get through. But I think the important thing about the eye is only 5 photons are needed to create an effect. But all I'm saying is that there is more to it. But fundamentally, you cannot be well without having a correct circadian rhythm that's in line with the actual sun. But you can still exist with indoor light, but not properly.
It just seems like we can't cheat nature as much
No.
as we want to. You can't. I mean, yeah.
But that's a really good question about what, in terms of celestial bodies, and the plasma and the ozone layers that makes the sunrise and the sunset be a subtly different frequency. But that's a really good question.
I want to touch on 2 more things, and then I'd like to move on to maybe cold thermogenesis. I want to mention what about, you mentioned holes, like the ozone layer. What about speaking about people talking about the holes in the ozone layer, allowing more UV light in that's toxic for us? And this is why people say you should slap on sunscreen so you don't get a sunburn. Is there some truth behind that, or?
Yeah, it's gonna make the probability of burning more likely, but a lot of it is, the reason people burn is they don't have a solar callus. It's because they've not been seeing sunrises, because the red light alters how we absorb and process UV light. So if somebody just goes outside in Australia at 12 noon, it's already pretty high solar yield. But then if you've got the hole in the ozone layer, it's just going to allow more through. But it's like everything, more isn't better, and it's all about balance. That yes, if you lay in a sunbed for 3 hours and looked at the UV light in there, even though UV light is fundamental for our health and well-being, too much of it isn't good either, because it's again all about the balance of the wavelengths. But on the positive side about the hole in the ozone layer, I'm pretty sure that non-native EMFs can go out of the hole, because that's the problem with those kind of light, is we're basically trapped in this sphere and it's acting like a microwave. And as far as I am aware, some of the EMFs can go out of the hole. Just for anybody listening in that part of the world that feels that they're doomed. So all I would suggest there is, with a hole in the ozone layer, you have to be much more strict about your sunrises and building a solar callus, and then you would just have to go in and out of the sunlight, because when the UVB's out, we're not really supposed to sort of bathe in it for 3 hours. It's better, particularly when it's strong, to go in and out, like animals do. They'll go out for a bit, then they'll go and find shade, then come back in again. So it's just this mentality of more must be better, which it isn't. And the example of the hole is a very good example that more UV isn't good, because it's not natural. The hole's not supposed to be there.
Yeah, yeah. And then one more question, and then we can leave the light. If, according to this quantum biology perspective, we can create glucose just through the POMC pathway, which comes through light, through ACTH, right? And through cortisol. From that perspective, can't a person just, allow cellular respiration, have oxygen, glucose, boom, you have energy. Why do we need food? And are there examples of people that have gone very long periods without eating food?
Oh yes, there are breatharians, but then I know breatharians because some people say they're making it up, but I went and spent time with them and learnt about it, and that they're also like quite very connected to nature. They're quite hippie-ish, so that when you actually look to see what they do, that they're always barefoot outside, they're in the sun. We get 60% of our energy from the sun and grounding anyway, and when you're out in red light, the ATPase can spin and produce ATP, and then so we don't technically need the food electrons to go down the chain. But also with the other energy systems in the body, such as the DHA system, the vitamin D, because they're outside a lot, they're not around technology, so they don't destroy their vitamin A and their DHA as quickly as we might do, because the kind of people that are breatharians tend to also live outside, so they can recycle the vitamin A and the DHA without damaging it, and therefore they may not need to eat as much seafood as often. I don't know how long breatharians can survive for, but definitely the ones I know that do it properly are they literally live outside. So it's more than one factor. Yes, you can make your own glucose by gluconeogenesis, and we can all do that. We can make it out of sort of fats or proteins. And also when people fast and do autophagy, they can break down old and damaged tissue and then use that to create energy. But the question is, how long could there are accounts of people not eating for years and years and years, so I'd have to investigate that. But the issue I have with that is, yes, you can go a long time living like a breatharian, but our hearts and our brains have so much mitochondria. There comes a time when we do need the food electrons to create ATP, and then also we still need certain nutrients, like I mentioned DHA and vitamin A, which are vital for our energy. We can make vitamin D, and then when it comes to the way their bodies process minerals, because minerals like potassium are vital for in the semiconductor system in the body. So whether they take on board minerals through water, because they definitely drink. So I think actually not eating food is something I'd have to look into how long, because people will say I'm a breatharian, but they might eat once a week. But it's definitely possible, but you have to be really connected to nature and really disconnected from technology to be able to do that. Because even if you were very connected to nature, if you're on your phone all the time outside, you're still going to steal your energy effectively and not allow this to happen.
Noted. I'll keep my phone at home next time I go outside. I've been cheating every time I go out. Okay. And I was also thinking not essential amino acids, right? Surely they would, they're called essential amino acids for a reason. We need to get them externally. So
True.
um,
A lot of it, this is actually something I'm really thinking about is first of all, I don't fully understand why the body would reject a mineral, because all you're doing is changing the redox state. But then with amino acids and things, we can make tryptophan and we can, in effect, recycle them. But also we do have plenty of stores of old damaged proteins that we can break down and mine the amino acids out. But then again, when it comes to essential amino acids, I think also we have huge stores of things. So we are primed to go for a given amount of time without anything. However, I can't see how people can not eat for sort of a whole year and still function. But there is a story about fasting. I think it's quite famous. The man who was a ridiculous number of pounds that didn't eat at all for 365 days, and he lost a huge amount of weight. So whether he's still alive, he'd be a good person to ask. But also you have to be careful with this, because what people count as eating, that they forget drinking, and there's a good chance people may have taken an amino blend and that's a drink according to them. So I don't know, but I do think we've got intrinsically very good ways of recycling things in our bodies.
hmm,
And if we don't break our vitamin A and our DHA, then that's very important. We can keep using that. But I think it's something that you might need to get a breatharian on to talk to ask
yeah,
in detail. But I know it's possible for us to go for much longer than we think without food electrons. And that's when you were asking about the leptin melanocortin pathway. Fundamentally, when people become more leptin sensitive and they have better mitochondrial function, and then I know you wanted to ask about cold thermogenesis, everything functions better. So the proteins in the respiratory chain get closer together, so they become more effective. So that means they need less food electrons, but they don't
yeah.
feel bad, because a lot of it is people feel awful, as in they want food more quickly than they actually run out of minerals and tryptophan and tyrosine and things like that. So there's the psychological side of not wanting to eat, but I think it's possible, and it's much easier to do than we're led to believe, because current society, there's food everywhere, and there's we're told we need to eat all the time. So part of it is like the grounding. It's perceived as weird to not eat, where it's actually we're supposed to do that sometimes. And if we have good functioning mitochondria, good circadian rhythm, good leptin function, then we do actually need less food electrons and we feel just as good.
Hmm. Okay. Um, and now I'd like to shift the conversation. Before we go into cold thermogenesis, this question has been burning within me ever since I listened to Dr. Cruz's work and listening to your stuff. Is if we want to go back to the KT event, right, the Cambrian explosion, and think about a span of 100 to 1,000 years where photosynthesis was blocked, right? So there wasn't whole lot of plants everywhere. And the beings that could fly towards areas where there were plants and photosynthesis was not blocked. But and then there were our little mammal ancestors that were kind of huddling up. And Dr. Cruz's theory is that they created UV light within them, and that gave them a source of food. My question is that completely and he says this too, that's not evolution, right? Genes don't change in a population that quickly. So am I missing something? Is this maybe an epigenetic change, or is this showing a possibility that living organisms can change rapidly if the environment is extreme enough? Well,
Oh yes,
am I missing something?
no,
Yeah.
definitely, because first of all, with that, the mammals and the birds and everything had melanin in their feathers or their fur or their skin, and you can, in the presence of UV light, whether you make it yourself or from outside, you can split water into an electron, a hydrogen, well, a proton, and molecular oxygen. So you straight away can create water. You can electrify or charge your water battery. So melanin can, to some extent, behave like magnesium in a chloroplast and split water. And once you've done that, it's an energy source. But also, when it comes to redundant biochemical pathways, so we all have them, and there are all sorts of pathways that are more ancient than others, and we don't use them because we will use like another energy system. So under those circumstances, I think personally, first of all, it was the melanin. Secondly, it was, as Dr. Cruz says, about being able to make glucose, but also there's going to be redundant pathways that got activated because the organism would either die or it would have to reactivate a redundant pathway. Because, for example, things like yeast use a different form of making energy than we do, that they do glycolysis a lot, and we can obviously do that as well, but there are other pathways in the body. So I would assume that it's I don't. The thing is, with the Darwinian theory, like you said, what happened then happened too quickly. So I'm just wondering whether the pathways were just dormant and they got activated as a survival mechanism, or whether, like you say, is Darwin wrong and we can adapt to our environment much more quickly than we are led to believe by traditional genetics. But I don't think anybody knows. But my question about the Cambrian event is, how did vitamin D play a role? Because we need UVB to make vitamin D. So my little brain's always wondering, do we have is vitamin D also able to be produced or made with UVA light? Because there wasn't any UVB around. So that's my other question about the KT event, that there are unknowns that we can postulate about, but I think it's just a good question. But the point is, it happened. So therefore, either we've got redundant pathways in our bodies that we can activate under extreme needs, or evolution and epigenetics can happen a lot quicker than we think. Because also there are numerous other scientists who talk about genes and inheritance aren't the only way to pass on information, like Rupert Sheldrake, for example, with morphic fields and the non-heritability problem. So there's already giant holes in our current views of genetics. So it could either be a morphic field effect, or it could be sort of accelerated epigenetics, or it could be activating redundant pathways.
I absolutely love Rupert Sheldrake. I think his work is just so fascinating. And whenever someone has a rebuttal against his answer, he always just answers really well, and is really articulate and knows his stuff. He's not just some hippie scientist. Like he's actually talking actual hard science.
Oh yeah, he's the most scientific, non-speculating person, along with Dr. Pollock. Neither of those two will ever speculate ever, and they're probably two of the most clever men. And I'd love to know what the theories they both have got in their head, because Dr. Sheldrake and Dr. Pollock will only say this is based on lots of science that we've done properly ourselves over and over, but they won't speculate. And I'd love to just, have a private conversation to find out what their theories are. Same as, because Dr. Cruz will say, oh, this is my hypothesis. And Dr. Stephanie Seneff has got lots of ideas of how this could be. And those kind of scientists are vital, because somebody can then go and test the hypothesis. But Dr. Sheldrake is very much, it has to be done scientifically. Same as with all these telepathy studies, the data is very tight, and there's loads of it. I mean, he's probably, and then there's obviously his amazing book, which is the one about the 10 reasons why science is wrong.
Science delusion.
Yes, the one about the speed of light not being constant, and there's all sorts of things. So he's really dug out the inconvenient truths and the things that scientists have stuffed under the carpet. And then he does actually proper science with proper experiments that are very simple to prove his idea. But yet his ideas are still not accepted, but that's just science for you.
Yeah. Okay, Dr. Pugh, I really want to thank you for coming on. And I hope to have you on for part 2. Is there anything, do you want to let the viewers know where you'd like to be directed, or where you can be found on the internet?
Oh yeah, I just go by Busy Superhuman, and there's Instagram, TikTok, and YouTube, and I have a website which is Busy Superhuman, or you can just type in Dr. Sara Pugh and you'll be able to find me and reach out.
Awesome. I'll put the links in the description, and thank you so much, Dr. Pugh.
Oh, no, thank you. It's been really fun to talk to you. And I'd love to come back to do part 2, because I think sometimes with long podcasts, people get such information overload, especially from Dr. Cruz or Dr. Seneff. And I can be like that as well, that it's just, sometimes it's nice to have things in 2 parts, because it's easier to digest for the listener, because I think it's so important to get these ideas and information out in a way that's understandable and practical for the listeners. so they can have more energy and feel better. Because I meant to ask you just before we close up, what was the main points or key things which helped you get over your chronic fatigue?
I'll tell you what, I made a video about it. The main two things were cold thermogenesis and the carnivore diet. And in my research, I realized that the link between them was mitochondria. And then I got exposed to Dr. Chris Palmer's work, and then I stumbled upon Dr. Jack Kruse, and it was just like an endless rabbit hole.
Oh yeah, CT is one of my favorite things ever. But CT is actually very, very scientific, so it does need its own podcast, because it's more than just making yourself cold. There's really interesting things that happen of us behaving like a semiconductor, how water properties change, all of the really interesting chemicals and things we release from our personal pharmacies when we do CT. So it's definitely something people should do. And with winter coming in my side of the world, people should make themselves cold and they'll feel the benefits. So that would be a great thing to dive into again.
Awesome. All right. Well, until the next time, Dr. Pugh, have a good one.
Thank you very much, Sam.
Bye-bye.